The project started with L3 Harris. They reached out to the U, and we got a notification from them, and they kind of introduced the idea of applying these technologies to cybersecurity, and I thought that was interesting, so I joined up.
They presented us the opportunity to use neural networks, and I had also been taking courses at that time about neural networks, and I was really excited to actually create a neural network from the ground up and use that in a real application like this.
Well, when L3 Harris pitched the idea, I really liked that it was really related to computer networking, and I love the computer networking class. I read the textbook page to page, so I was really excited just to use that knowledge.
I was excited at the prospect that L3 Harris had an idea that would solve a real-world problem. I thought that cybersecurity was a huge issue, and any way that I could help address that problem would be a valuable experience for me.
Intrusion is a web-based cyber threat detection system which determines whether TCP flows in a network are malicious. It provides contextual information surrounding attacks as well as visualizations for further insight. It is backed by a convolutional neural network trained using the public UNSW cybersecurity dataset. Take, for example, Bob. He works as a cybersecurity analyst at a startup company, and they're planning to launch their new social media website and are expecting a lot of unknown traffic. It is up to Bob to identify the devices that are involved in this traffic and also determine if there were any signs of malicious activity. The first step is to log into intrusionweb.com. You can either sign up or you can just use a Google account, and once you select a Google account, it'll ask for certain permissions and then you're in. Next, the user will want to configure the devices on their network. For this, you can head over to the Configure tab. Once you are in the Configure tab, we will add a device onto our dev network. For this, we can input the IP address in the IP field, and we also have some additional options that we can configure, such as the device alias, we'll name that dev3, and the group that it belongs to, dev network. After configuring the devices, the user will want to run a new analysis, but before we run an analysis, we need to capture a packet file. To capture a packet, we will open a new terminal on our device. In the terminal, we will run the TCP dump command with the D flag to indicate all the networks that our device has access to. The first network, ENO0, usually corresponds to the Wi-Fi or Ethernet network. To start capturing packets, we'll run the TCP dump command again. We will choose the ENO network. We will add the TCP flag to only capture TCP packets. We will name our packet file. We will indicate the amount of packets that we want to capture. In this case, that's 10,000 packets. And finally, we will add an S flag to prevent packet loss. As this command is running, it captures all the activity that is happening in the background. After this command is finished, as we can see, we have successfully captured a packet file. Once we have our packet file, we can head back to our dashboard and run a new analysis. To run a new analysis, we will name our analysis Analysis 1. We will select our packet file that we just captured and we will click the Run New Analysis button. After a few seconds, the server will respond with whether or not it detected malicious behavior in the packets. In our case, it detected two transactions that are malicious, one of type generic and the other of type exploit. To get more information about these attacks, we can click the review button. Here we can see what our classifier's top 3 predictions were. It predicted generic type with 42% likelihood, as well as fuzzers with 9.4% likelihood. And you can click the buttons on the side to view more information about the attack and the steps to mitigate it. It also shows the devices that were affected and all the devices that were grouped along with that device. The user can also confirm or deny the attack based on the information that they have received. Doing so will aid our visualizer.
To enable deeper analysis into malicious activity that may be taking place in a user's network, we provide a tool that allows users to visualize potential attacks. This can be accessed by clicking the Visualize button on the sidebar. By default, we are showing a visualization of the predicted attacks in the most recent analysis and any configured devices that were affected. In this visualization, the larger red nodes represent malicious transactions, the smaller yellow nodes represent the features of those transactions that have been extracted from the network traffic data, and the larger blue nodes represent a device configured on the network. The edges between transaction and device nodes show that this device was affected by the predicted malicious activity, and if we inspect these edges, we can see that both of these attacks were predicted from outgoing transactions from the Dev1 device. By hovering over the nodes in the visualization, you can see more information on the transactions, transaction features, and the devices in the visualization. By selecting the Configure Visualization button on the lower left, we are given a number of ways in which we can filter the data that we wish to visualize. Let's start by viewing the other devices in the same group as the affected device shown in the visualization by navigating to the Devices tab and selecting that group to view. Now we can view and inspect the other devices in this group that which may be useful in determining which devices should be investigated as potential targets of the attack. Now let's try comparing the attacks in this analysis to past confirmed attacks on our network. Open the Filters modal again, and under Analyses, select Analysis 1 and Past Analysis 2 to compare these. Then, in the Transactions tab, navigate to Filter by Confirmed Status and select Confirmed and Unknown, and then apply the filters. Now we can see that another device in the same group was confirmed to be affected by an attack, and we can analyze the common features shared by our new predictions and the confirmed attack. While these are just two examples, our visualization tool offers a host of ways in which a user can view and analyze their network data so they can get a full picture of what is happening in their network.
In terms of our tech stack, we created our front end in React, which communicated with our ASP.NET back end. We stored all of our information in Neo4j graph databases, and we created our classifier in Python, more specifically Flask. And finally, we created our neural network using PyTorch. Over the course of 2 semesters, we completed 94 issues and made 336 commits. We also integrated our tests into a CI pipeline to ensure smooth releases. Throughout our development process, we conducted 2 user studies and worked closely with 13 people, including L3Harris engineers, and made significant improvements to our visualizer using their feedback.
The features of our application have the potential to identify and resolve serious cybersecurity threats. To try it out for yourself, visit intrusionweb.com. For more information about the project, the team members, or to see a detailed user guide, click on the logo on the homepage or visit /about. Finally, we are very grateful to our industry sponsors at L3Harris and to the teaching staff, who have been providing regular guidance throughout the capstone course.